So we have reached the full hour and we are going to commence with the Vector Forum and today presentation. My name is Christof Ebert and I'm responsible for the consulting activities in Vector worldwide. And today I'm with Gerd Hoefner, and I suggest that Gerd, you briefly introduce yourself and we move on from here.
Yeah, thank you, Christof. Well, as Christof said, my name is Gerd Hoefner. I'm with Siemens Healthineers. My background is in computer science, so I studied computer science in Erlangen and then started working with Siemens back in 1986, so 38 years ago. In the meantime, I've always been since then with Siemens or affiliated companies active in different areas, but all closely software related. The last 20 years, more or less, I spent in India being responsible for the in-house software R&D first of Siemens and then of Siemens Healthineers. And I returned to Germany back in January last year, and my current responsibility is to look after operational excellence in software engineering at Siemens Healthineers.
Thanks, Gerd. And I will make a brief intro to the topic and also to position what we are going to hear today. And from here onwards, we then have the presentation. So Forum this year is called Converging Systems. Why? Because we see an increasing amount of software systems, which is not anymore here IT or here embedded, but it's converging. We have IT in the product. That is what we used to call embedded, but it's not anymore frozen. It's adaptive. It's enhancing. It's oriented to user need. And maybe most important, we have software-defined systems increasingly. And that means the system platform can be kept for a while stable, but the software is changing. The advantage, well, you don't need to make so many hardware updates. It's more ecologic and certainly also less effort for the maintenance. So this convergence has a lot of impact, and this is why we decided to put this in the focus of our Vector Forum 23. Few words on Vector. We're about 4,000 people worldwide with offices in practically all continents. And we have been working in different domains, notably testing, embedded software, and recently also the other side of the stack, as I just outlined, with cloud and service-oriented architectures. And my responsibility here in Vector is the consulting activities. We serve different industries, and that also means it's typically one common aspect, which is it's safety critical, it's mission critical, and that is why today I'm very glad to have Siemens Healthineers and Gerd Hoefner, because it indicates also the challenges which we have with software in the medical domain. Vector Forum looks into the different portfolio elements of Vector Consulting, which is trust, safety, cybersecurity, technology, technology introduction, service-oriented architecture, etc., transformation like agile, and trainings. And that is also where we have positioned the Vector Forum this year. A few things just to have the necessary background, how this all runs. We have about 10 minutes introduction. That is what is now ongoing. We then have the half-hour presentation. We have a Q&A, which is live. So all those who listen directly, you're invited to put your questions up in the chat box. So Teams has this possibility to have a chat. You just type your question. Others can vote on this question with the like. You see this on the presentation here, which is a screenshot. You can click on this thumb up, and then we just can count which questions get most of these likes, and we will address the question in the order of these votes. The questions can be entered from the beginning, but obviously it makes sense to wait a little bit in understanding what will be presented by Gerd. We will have in the end also a mailing which gives you a sort of a wrap up. There is also a quiz which you will receive a link in this mail where you can participate and also can win books or trainings. And one technical aspect you might all be aware, the more you rely on the cloud, the more you are also doomed to trust the cloud services. And that means we cannot always guarantee perfect performance. Microsoft Teams was down in January for a while, a half day, and this is out of our control. In this case, if you see it failing, try again to log in, because it might be your own environment. If it doesn't work, check your email. There should be then a notification. We will then move to WebEx. And I suggest that everybody mutes his microphone so that we can not have so many disturbances from the background. That's the disadvantage, but also that shows that we are really live, and you can use the chat if you want to communicate. That's a bit smoother, and everybody can listen then to the presentation. On the right side, a few things which I consider relevant. Look where the emergency exits are. That's always important, independent where you are. We will take the hour. You will get a PDF afterwards. Look that your online connectivity is good enough to facilitate video connection. And as I said, questions in the chat box, and help yourself with a coffee. That keeps you awake and certainly even increases your interest into the presentation. Now, why do we talk about converging systems? I explained already the technical background, but another one comes from our annual survey, which you see the result here from year-end 22. We ask on short and midterm challenges every year. And the one big surprise to me was that competence is perceived the biggest short and midterm challenge. And the lack of competence impacts many of these other challenges, because you would not have enough people to focus on first time right, to focus on quality, and that means you will have more rework, you have more risk. Complexity would increase because you have less ambition for refactoring and for controlling complexity. Innovation capabilities decrease, and so on. That means the lack of competence, which we observe in many companies with respect to software competences, that would have dramatic impact, and this is also why we should have a good look into competences. Now, one competence is to not reinvent, but rather see what's around. And when we look around into the major trends, we have seen over the past years something which was already indicating this convergence. It was called initially the fourth industrial revolution, then it was called Industry 4.0. Some call it ACES, which is autonomy, connectivity, ecology, services. And also interesting, we had already 10 years ago, written an article together with Accenture in IEEE software, which had a couple of recommendations, which I will briefly underline, which is to innovate business, because that's a key in these converging systems, that we adjust our business model, focus on value delivery, think global. And here Gerd Hoefner is a good example. I visited him a couple of times in Bangalore, in India, and in the world today is a global village, as one might say. We depend on each other for the good. And that means it's also important that we manage such global development. Deliver quality. I mentioned already, lack of competence directly impacts quality, and many companies struggle with insufficient quality. And, well, to close this loop, grow the competences. That being said, our Vector Forum has today its fourth installation. We had already presentations about transformation with Gerd. We looked into standards, which ensure consistency. We had looked into global development, notably Costal in China, and today would be on AI and digitalization in the healthcare sector with Siemens Healthineers and Gerd Hoefner. And all that would also be later available on YouTube. We keep you posted so that you also get this. We have all presentations always 1 o'clock Central European summertime. That makes it accessible for Asia and America. Glad that those of you who are live participate. Those of you who look to the recorded version, you cannot ask questions, but you will still learn a lot. And that means when we talk about digitalization, a key question would be, there's an increasing amount of AI deployed to automate engineering business workflows. So question to you, and this is now the survey, what's your feeling? Do you consistently deploy AI to automate your engineering business workflows? Yes, means yes, I or we deploy. No, we are not yet there. So you see that small window, can just click yes or no, and then we will see what would be the result. I wait a minute and then continue here. The survey is anonymous, so your name would not be saved with the answer. In the meantime, let me just focus on a few things before I hand over to Gerd. Healthcare, digitalization, AI. What it means is digital transformation, or DX, has evolved from a, let's say, simplistic workflow-oriented IT topic into a real big transformation across all industry segments. One of the focus area, if we forget on technology for a moment, is customer. It's customer perspective. You all know from online shopping, we have an increasing focus on this single segment. You are the target of advertisements, you are the target of sales, you are the target of all what could make you feel better. This is what we call the customer focus, but that also means it needs excellent software engineering because there's a lot of dependencies. And when we see initiatives around AI and digital transformation, we see many failing because the software was insufficient, performance was insufficient, the architectures did not work as expected. And this is also where we position ourselves to help companies in this evolution across industries. So looking to the survey for a moment, we see it's about 3/4, 75% is a no, 25 is a yes. And with that being said, I think we now are prepared to move on with the presentation of Gerd Hoefner. And Gerd, here's to you.
Thank you, Christof, and let me share my screen with all of you. So, Christof, maybe you can let me know. You see my screen?
We see. Perfect, yeah. Okay, maybe you can enlarge the picture.
I'll put it in presentation mode.
Yeah.
And then we are ready to go. Let me go to the first slide.
Yeah, perfect.
So, welcome again. And the next half an hour, I will talk about enabling healthcare through digitalization and AI. But before we talk about healthcare, let me talk a little bit about digitalization, what it means at all, not necessarily only in healthcare, but I would like to look at one example, and most of you probably also might have heard the famous quote from Marc Andreesen back in 2011, so 12 years ago, where he said more and more major businesses and industries are being run on software, delivered as online services from movies, agriculture, national defense. And over the next 10 years, I expect many more industries to be disrupted. And from my point of view, the industry where you can see this disruption the best is the music industry. It was one of the first industries to be disrupted by software. And it also, let's say, the impact the software had on the music industry are, let's say, in a way that the business models got changed, ownership got changed, also the way music producers, the bands, are earning money. So if we go back in time a little bit, so the phonograph was invented in 1877. So the record player, And at that point in time, I mean, till the first digital revolution, when you were listening to music, you were using a medium, which you see below, the long playing record, which you had to put on the phonograph player. And the first revolution, digital or first digitalization, was the introduction of the CD player. So that was in 1982 when Sony launched the world's first commercial CD player. And what you can also see is the size of the medium significantly reduced from, let's say, a record has a diameter of, let's say, 30 centimeter, and a CD has a diameter probably of 10, 12 centimeters. But what also changed in this transition was the behavior in the way how you had to listen to music or how you could listen to music. Because with a long playing record, you were more or less forced, you could say, to listen to a complete side of the album. And unless you got up in between and moved the needle back from, but otherwise, usually when you were listening, let's say, to the full album, side A or B. With the CD player, you could already program the CD and listen to dedicated songs. You not necessarily were forced to listen to the complete album. And the next revolution, MP3 player, when the whole thing became mobile, that was back in 1997. And the last revolution that were online streaming services. The first one that was Rhapsody, and that was launched in 2001. And the thing is, what changed here significantly compared to, let's say, the times when we had a record player or a CD player is that with the streaming service, you don't own the medium anymore. Yeah, when you buy a CD, when you buy a long playing record, then this is your own possession. With the streaming service, in principle, the model is that you have the right to listen to the music which is offered from the streaming service. If the streaming services decide at some point in time, for whatever reason, I mean, some of you, maybe the older generation, may have realized or recognized the cover of the LP Pink Floyd Dark Side of the Moon, released 50 years ago in March 1973. If the streaming service decides to remove Pink Floyd from its list, then you won't be able to listen to this anymore. So the ownership has changed, the model has changed, and usually also with the CD as well as the LP, you still had, let's say, the complete album in your hands, whereas the younger generation with the streaming service, they not necessarily will download the complete album or listen to it, but only selected songs, the songs they like to listen to. And if you look at the income for, let's say, a band that produces music, in the past, main income was from the albums. Today, the main income is from the tours. And if you look at it, also the cost for the tickets to attend, let's say, a concert has, because of that reason, significantly increased. I remember back in 77, I was in Frankfurt visiting a Pink Floyd concert, and the cost for the ticket was about 20 Deutschmark, more or less the same like for the album. Today, tickets for such kind of bands are in the range, they start, let's say, 100, 150 euro, and they go up to 300, 400 euro. So the source of income for the bands is no longer the records, but the live concerts. Yeah, and question, of course, is for us in healthcare, what does this mean? Number one, what is important to notice is if you look at the innovation cycles, they changed from almost 100 years, 1877 to 1997, to the about 15 years, and then in the meantime only to 4 years. And now there's something, my animation, the slides are not moving. Just give me a sec because I wanted to switch to the next. You can still hear me and see me, Christof, right? Then let me see. Click unshare and share again the screen. Now it works again. Okay. So here you see the innovation cycles from 105, 15 years, 4 years. The other thing is, if you look at us as a just food for thought, I mean, we at Siemens Healthineers, we are, or our main business today is providing equipment for diagnostics, for advanced therapies, for cancer therapies, and diagnostics both, let's say, for the imaging modalities, as well as also the in vitro as well as in vivo diagnostics. But the way I look at it from a software point of view, we are the ones who produce the record player. And the big question is, well, you still have people who are, let's say, buying record players today, but how will it look like in healthcare in the future? And if you look at it, I mentioned this quote from Marc Andreesen, "Software is eating the world." There was an article in December 2022 from McKinsey Quarterly, where they said Marc Andreesen's observation from more than 10 years ago that software is eating the world needs an update. They said software is the world. So it's no longer about software is eating the world. They clearly say today software is the world. And they also say that software industries continue to grow at a massive clip, and more traditional companies are realizing that to compete, grow in a digital world, they must look, think, and act like software companies themselves. I thought that I got stuck again, but now it moves to the next slide. What they also said, if software is the world, then every company is a software company, no matter what kind of business they are in and what are their products. They say there are 6 must-dos to succeed. Commit to a software culture, invest in empowered product managers, drive engineering excellence through autonomous teams, flexible architecture, win at software by playing the ecosystems games, build a specific software go-to-market capability, and find and keep talent by focusing on mission and work environment. I won't get into all those 6 points, but let me talk a little bit about what it means to commit to a software culture. And for me, the best example today of a company that sells, well, material goods to some extent, but is still a software company, Tesla. Yeah, so if you look at this, Tesla on one hand has the setup they have with the software. So the whole approach, you could say, it's a software-centric modular system with a standardized and modularized central software architecture. And they have independent modules enabling ongoing incremental innovation over the air. The hardware is designed for flexibility and variety, and they have an optimal protection against cyber attacks, whereas the traditional OEMs, they have a non-hierarchical hardware-centric approach with high complexity due to the interdependencies between the modules and large numbers of ECUs. And well, I think, Christof, you mentioned during your introduction the term software-defined system. And this is, from my point of view, a perfect example for a software-defined system. And also the philosophy of Tesla is when you better over time, that means when you buy a vehicle today, and compare the same vehicle, how it performs in 2 years, what they promise is that it's a better vehicle in 2 years, not because of hardware updates, but because of improvements which they provide through software. And I mean, sometimes we have discussions internally in the company because I always say, for me, Tesla is a software company that sells cars and provide also, of course, an infrastructure for that. Well, maybe you can argue it's not necessarily a pure software company, but the thing is, they have a high standard in software culture and they think software and not hardware. And this is something, if you look at most other areas in automotive, there is still, let's say, the traditional OEMs are thinking which is hardware centric and not necessarily driven by software itself. Now, coming back to healthcare, I would say overall, the healthcare industry is the ultimate challenge for digitalization. And compared to other industries, which I presented before, music industry or automotive, you could say, depending with which industry you compare, but it's probably, well, 10, 15, maybe 20 years behind when it really becomes to the digitalization. But there are also clear reasons for that, because healthcare is probably one of the most challenging industries when it comes to digitalization, because it's about human lives. Yeah, if something goes wrong in healthcare, people can die. It's about trust. It's about privacy. If you are being diagnosed, you not necessarily would like to know that your whole neighborhood get the results. You have complex interconnections and established structures with insurance companies, with hospitals, with doctors, and so on and so forth. So this is really, let's say, the ultimate challenge for digitalization, and where it is really, let's say, a challenge to drive this and digitalize the whole healthcare industry. But at Siemens Healthineers, I mean, this is something to master this ultimate challenge for digitalizations. There are unique capabilities required. And we firmly believe at Siemens Healthineers, we do have those capabilities. Our unique capabilities are in the area of patient twinning, are in the area of digital data and AI, and in the area of precision therapy. At Siemens Healthineers, we aim to make medicine more accessible, efficient, sustainable, and humane for everyone. And let's not forget that sharing in scientific progress and its benefit is a human right, and as it is the right to the highest attainable standard of health. And we are also convinced that digitalizing healthcare systems can make a significant contribution, and shadowing the patient in the digital domain end to end will evolve as the key enabler to highly individualized precision therapy. And this is when we talk about patient twinning, this is about the personalization of the diagnosis, the therapy selection, and monitoring after care and managing health. With the digital data and AI, we will leverage the digital available information and advance the provider's operations with tech-enabled and enterprise services. And finally, with the precision therapy, we will provide intelligence, image-guided treatment for the most threatening diseases. And our unique capabilities are based on key technology areas which are interconnected. So what we see is a great potential in the development of artificial intelligence, sensing or sensor technology, and robotics to improve medical care. In the future of medicine, digital patient twins, which is something we are working on, will help patients to be treated earlier and more precisely. So what you see here in principle, this circle shows you have the real patients, where we have the sensing with our imaging modalities, with in vitro biomarkers, optical perceptions, vital sign sensors, or wearables, for example. And we have the robotics for the lab assistants robotic catheters, radiation, patients, and all this kind of topics. And then you have the artificial intelligence, or the software, you could also say, with data access integration. And this provides the ability for, well, high-end decision making based on the digital twin. I will talk a little bit more in detail on the digital twin later on when we have an outlook. But let me first talk about the combination of our unique capabilities: patient twinning, precision therapy, digital data, and AI, and the 3K technology area: sensing, artificial intelligence, and robotics. And with this, with the patient-centered innovation, we ensure that we have better outcomes and experiences. So we are using model-based on algorithms and large amounts of data. We are trying to better understand the people's health status in order to predict changes, plan personalized treatment options, and improve outcomes at reduced efforts and increased patients' experience. Our goal is for people to live longer and healthier lives while saving critical resources in the healthcare systems. We already know today, for example, that diagnosing various types of cancer as early as possible drastically increases the chance of recovery. And overall, how we call it, our overall objective is really in combining, let's say, the possibility of the diagnosis and the treatment, that we have a world without fear of cancer. This is also the vision of the one part of our company that looks specifically into treatment of cancer, and this is Varian. Now, let's have a look at how intelligent machines powered by AI will be at our core, shaping precision medicine for a better healthcare. And there I would like to talk about 3 different levels: today, tomorrow, and in the future. Today, we have automated products and solutions which minimize unwarranted variations. We do have intelligent automated devices with push button features. We have task procedure specific integration of sensors and devices. We have a reduced variability and improved precision for diagnosis and procedures. And we use workflow optimization and reduced operating cost. Tomorrow, we will have intelligent machines that enable precision decision making with real-time decision supporting. We will have machine learning powered image reconstruction and post-processing, shifting features from hardware to software. We will have bidirectional interaction of hardware and algorithms and design and operations. We will have new, precise and timely supply of data from networks of sensors, machine learning, optimized automatic procedures and workflow in labs and hospitals, and digital twins both for products as well as for the solutions. And in the future, we will have connected intelligence that expands the healthcare availability. So the availability, remote operations of procedures, precision medicine-based pathways, which are augmented by virtual reality and augmented reality, in human digital twin and self-learning networks of machines. And even today, we already have digitalization and AI in our portfolio at Siemens Healthineers. Here are 2 examples. On the left side, what you see is the Synco Virtual Cockpit, which is a remote scanning assistant improving access and provider productivity. So with the Synco Virtual Cockpit, you are able to have a more flexible deployment of experienced personnel across different locations. It also enables higher level of standardization in reports, leading to more accurate diagnosis. And it also improves significantly the productivity in case of personnel shortages. Another portfolio element where we already have, let's say, AI in our portfolio are the so-called AI Red companions. This is AI-based software assistance for image reading Typically, it is dependent on a modality and a body part. So, for example, we have a AI red companion for chest CT reading or for prostata MR reading. And what those red companions, red by the way stand for radiology, what they do is they automatically highlight anatomies and abnormalities of multi-organ areas, including also the incidental findings. They also transfer the results in structural reporting. And we are working on a whole number of different such kind of companions. I mentioned too the chest CT and the prostata MR, but there will be many, many more that will be available. And well, if we have an outlook, there will be the lever to move us from image analytics to a digital twin. So our overall vision, what you see on the right-hand side, is the digital twin. Today, besides what I've mentioned, the AI Red Companion and the single virtual cockpit, we already have more than 50 AI-enriched offerings. We also have a supercomputer called Sherlock with a computer power of 24 petaflops, and we do 600 AI experiments every day based upon more than 1.1 billion curated images, which we are using to train the algorithms. Tomorrow, we will have true AI offerings with a high automation. And we also, let's say, when you talk about the digital twin, the idea is that you really, let's say, have a copy of an individual where you can simulate the impact of treatments, where you can also simulate, let's say, the impact not only of treatments, but also of, let's say, changes in the body, and then have an idea how, let's say, an individual develops. And well, I will talk about this as my very last slide. And well, if you have, let's say, everyone uses the digital twin in the daily routines, we also bring the patient digital twins to the clinical routine. So that means the use of artificial intelligence in everyday clinical practice is no longer science fiction. In the future of healthcare, it will be indispensable for translating the growing volumes of data into decision-relevant knowledge. The technology has the potential to significantly improve the access to high-quality healthcare and also improve diagnosis and therapies, not only in highly specialized centers, but also in remote, poorly populated areas or emerging countries. So what we do is when we bring the digital twin to the clinical routine is shown here in this picture. We are mapping the reality into digital with the automated AI-based organ mapping with Syngo, what I've mentioned before, and also the red companions. Then we can do the planning, the travel with the dynamic data and the simulation of the expected time of arrival, which basically means if you transfer this idea onto the healthcare, then you have the planning and the outcome simulation for your radiation therapy. And then hopefully you will also know at what point in time, let's say, the treatment will be successful. And the last topic, the augmented point to real-time routing, is then what you see down here on the right side, the adaptive treatment delivery. And this is in principle, if you look at it, when we talk about digitalization, what everybody knows today, this mapping reality into digital, you could say this is Google Maps, and then you have, let's say, the planning, travel with the dynamic data and the time when you will arrive, up to the heads-up display with the augmented point to point real-time routing. And if you transform or translate this concept into healthcare, then you have these 3 steps: the automated AI-based organ mapping, then you have the planning and outcome simulation for the respective therapy, and then the adaptive treatment delivery in the end. And well, if we use the digital twin, then it could also serve, let's say, as a wellness coach, predicting individual risks and preventing sickness. So, however, the extremely high demands which are placed on its application to humans is also something that you need to keep in mind. On the one hand, the data quality, of course, has to be very, very high. And on the other, we need secure and transparent access to health data. Both requirements are prerequisites for the successful realization of the digital twin. In my opinion, there are still no satisfactory solutions today. And I mean, also the knowledge of how the human body works. A colleague once told me that I mentioned that I'm a computer scientist by background, not, let's say, medical doctor, but a colleague once mentioned to me that the knowledge about the human body, which is available today, covers probably about 30% of the complete way how a human being functions. So that also means that there are not many unknowns, and not sure if this will really be all discovered and known, that we at some point in time can be aware 100% how a human body functions and in this way simulate it. So we are sitting on a treasure trove, of course, of data, and we haven't been able to access it so far. And we need to find a solution that lets us access and process a large amount of data securely, efficiently, in accordance with the relevant legal framework. And this is the only way we can leverage the full potential of digitalization in medicine for the benefit of all patients everywhere. And our vision, or you could say there are 2 visions in this picture, is on one hand, a lifelong digital twin, electronic patient record, and then that you also have, let's say, a personalized computational model continuously updated with new sensor data, with new scans and examinations. And then here on the left-hand side with the orange shirt, you have the individual, and next to him, his digital twin. And the person is well, and we have a continuous monitoring how the wellness. I mean, of course, there will be ups and downs, but there will be, let's say, you could say, a range be defined where you are still considered being well. And if you have, let's say, if you cross a certain boundary, then it will lead into sickness. At the top, you have it as well as in the bottom. And the digital twin could serve as the wellness coach by the prediction of the individual parameters, and in this way ensuring that you always stay into the respective sector where you are well. And sometimes I also feel, I mean, we talk about healthcare today. What we are doing, sometimes I say it's not necessarily healthcare, it is sick care, because people typically, they go to a doctor once they are sick, when they become a patient. And here, in principle, the overall vision could be to ensure that people lead a lifelong life in wellness. And that brings me to my last slide. At Siemens Healthineers, we pioneer breakthroughs in healthcare for everyone, everywhere. Questions? Christof, I think you're still on mute. And I will unshare my screen.
And
people can see me if they have questions. Welcome.
Thank you very much, Gerd. And we start with the questions. And one got most votes, which is, with an increasing amount of AI to automate medical workflows, decisions become less transparent. So what is meant is probably how the AI is working. How do you verify and validate to achieve trust in AI for medical systems and workflows? So it's about how to verify what's the...
I wouldn't fully agree with the statement that transitions become less transparent, because the AI today is only a system that supports the medical doctor. It doesn't replace the medical doctor. So the final say is always with the doctor. And by the way, I myself recently underwent a scan at a doctor where they were using our Red Companion software. And I had a long discussion with the doctor, and he very much appreciated, let's say, the support from the systems that we have, because it enables him, let's say, to concentrate, let's say, on the critical things on an image, and it helps him to increase the speed in terms of reading more images every day. But in the end, the idea is not that the AI replaces the medical doctor. Then coming back to the question, what we also do is to ensure that our AI is best possibly being trained is the sheer number of imaging that we use. Yeah, because at the end, what is of utmost importance for the artificial intelligence, for the algorithms, is, let's say, the number of pictures, images you have to train the AI, but also the quality of the images. And I think I mentioned it before. Today we have more than 1.1 billion curated images, and all those images are also being reviewed by medical doctors about their accuracy, that they are really of high quality before they are being fed into the algorithms for the training.
Okay. So what we understand is it's not yet, let's say, a closed loop with AI. There's always the human still to make the final decision about diagnostics or surgery. Full different question with a high vote is about technology change. If I interpret correct, it's a very long sentence. I try to put it in two parts. So do you have recommendations how to achieve acceptance in a team for what this person called new and scary technologies? I mean, innovative technologies, you can also say, like AI or machine learning, especially in organizations which are traditionally managed. In other words, many organizations have organically grown. People also have, let's say, certain professional experience over many years, and suddenly came these disruptive technologies. Do you have any recommendations how to, make them open for such changes?
Yeah, I mean, this is a standard question for change management. And I mentioned before, if you look at this for software engineering, that applies in the same way. I remember when I started back in '86, requirements engineering, everything was still function-based. In the late '80s, early '90s, object orientation came up. In the early 2000s, Agile, Scrum, and all this kind of topics. And the ones who were still developing, let's say, waterfall, they were scared of applying agility. From my point of view, you should have, let's say, standard change management technologies, and then maybe have a small team of pioneers who are, let's say, coalition of the willing, who are interested in those new technologies, and that they evaluate it, apply it, and then if they are successful, simply sell the success stories to the rest of organizations, and then all of a sudden the appetite will also come from all the others. Yeah, but if you enforce it, it's always a challenge. Yeah, because enforcing, there will always be many people who will prove that it definitely won't work. Yeah, and if somebody would like to prove that something don't work, they will always be successful. Yeah, because it's you could always say they will sabotage the new technologies. So have a small team of people who are open to the new technology, who are not scared. Let them work on this, and then once they're successful, sell the success stories, and then others will follow step by step.
Let me ask a follow-up question. I mean, you have been working for some decades in India, leading the Healthineers software development. You come back to Germany, I think 2 years ago. Now, do you see a culture difference with respect to openness for change in technology?
Absolutely. But that also, the thing is, in Germany, what you need to keep in mind when you talk about culture. Yeah, I mean, first of all, cultures are completely different. I mean, it's not good or bad, but the motivation in India, if you come, let's say, from a relatively low standard of living, and by improving with new things, you can increase significantly your standard of living. You are open to everything. And if you are, let's say, at a very high standard of living, and if you look at Germany, probably we are among one of the countries with the highest standard of living. What matters primarily is preservation, that you preserve your standard of living. It also means that you are not necessarily as open to change as somebody who knows, if I change the things, I can move up in the standard of quality, in the quality of living by a level. Next topic is average age. I think in Germany, in our society, average age is 45, 48, something like that. In India, it's 27. And also, if I look at the average age in organization, I mean, the organization in India we had for Siemens Development Center, we were close to 5,000 people with an average age of close to 30 years. In Germany, if you go in an R&D organization, my guess is that the average age is like the German society, anything between 45 to 50. I don't say that people, when they get older, they are not necessarily open to change anymore. That really depends also on the individual. But the situation in India is a completely different. You have younger people, and they know that their lives can be much, much better than the lives of their parents if they are open to change, and they would like to change the world.
I would agree. I mean, I've also seen the different cultures. We discussed it a while, but I think it's good to have this kind of insights from you as one who had really worked in these cultures and led big software organizations. We have time for one last question, which is, you mentioned in the beginning the need to invest in empowered product managers. I think that was on that McKinsey slide, but yet we also discussed about that topic before. What exactly makes software product management challenging? And I mean, software, specifically software product management challenging, and what are your recommendations? So what's the difference, and what would be your recommendations?
It wasn't about software product management, but it talks about product management per se. The idea is that the product manager today, their mindset is in an area or is still, let's say, to a large extent hardware focused. And what has to change is that instead of hardware, you also, let's say, have a special background in software. That you also, when you design a product, that you decide what kind of functionality is being delivered by hardware and what kind of functionality is being delivered by software. And I once had a discussion with a good friend of mine. I won't mention the company, but anyway, that was in the business of mobile phones. If you look at, let's say, the last, let's say, 20 years, how the complete ecosystem or the environment of mobile phones has changed. 20 years ago, there were companies like Siemens, Bosch. They were still selling mobile phones, and Nokia and so on and so forth. Hardly any or none of those companies today you see anymore. And I once asked the VP R&D of one of those companies when they got out of the business. So from your point of view, what was the big mistake that you did compared to other companies? And he said, the answer is simple. Most of the functionality in our mobile phones was in hardware, whereas competitors had more functionality, significantly more functionality than us in software. Now, if you have a functionality in software, then you can update it every second in principle. If you have it in hardware, you need to wait till you have the next release. And even if you release, let's say, every week new mobile phones, the hardware, which you won't be able to, when it comes to production and all this kind of thing. So it's impossible, more or less. You will always be running behind. Of course, you can always argue there are functionalities that have to be provided in software. It can't be, for example, if I look at our modalities, of course, if we have an X-ray beam, there needs to be a generator and so on and so forth. There is definitely hardware. But the challenge is for a product manager that he really analyzes the whole system and then tries to maximize the number of functions that are being provided in software. And that is, again, Christof, what you call the software-defined system, that you have the mindset in especially the product manager that he thinks of system as software-defined system and not necessarily hardware-defined system as it is primarily today.
Good point, and also good conclusion to round it up, because we have always this discussion about what the difference of a software company to a traditional company. You gave a very good answer. And I look to the watch. We have not much time left, so let me just conclude and also look a little bit forward. But of course, first of all, thank you, Gerd, for this really good presentation, which spans from software systems evolution into medical applications in Siemens and Siemens Healthineers. And I will just go back to the presentation. It should now be shared. So where do we go from here? I mentioned this already with dated observations, what would be the need with respect to convergence. And I think we learned with the presentation of Gerd Hoefner a lot out of the medical sector, but also spanning the whole world of software, what it means to innovate the business. Just the last answer gave all the emphasis that you don't just continue the way you have been working before, but you have to really reassess architecture. You have to assess how you position yourself in business, focus on value, make what you deliver a value. And we have seen that with many examples from the healthcare segment. Think global. Well, we have seen development in many countries. Give the benefit that you also merge different cultures. And I see that as a big value. It's not here one culture, here the other culture, but more to benefit from a culture merge. And yeah, deliver quality. Make sure that what you deliver is good enough for the specific target and fulfills the requirement. You mentioned also the topic of requirements engineering, which starts the whole value cycle, and the growth of the competencies. We had this good question about how do we become more open for change. And this is really also a competence topic, because if people are insufficiently, let's say, trained, insufficiently aware of the technologies, and you mentioned a lot of technologies over the, let's say, past 3 decades, which came around. Once you know about it, once you are trained, it's much easier to facilitate a change. So we have seen good examples in this presentation. Thanks again. Looking forward, we will have still 3 such vector form presentations this summer. We have next week on the 7th of June, software production for high performance system in cyber physical systems from ZEISS. ZEISS is a market leader in precision industry. They deliver the optics, for instance, and all the optical control for the production of wafer systems worldwide. It's a leading company similar to Healthineers in that domain. And after that one, we will have code quality and software quality analysis, and finally a presentation out of public transport. So still different industries, a lot to learn. And we continue next year Vector Forum, where we go into more technology focus. You can already note the scope. We have also registration already open so that you don't miss the event. And that being said, and looking to the watch, it's 2 o'clock here in Central Europe for those who attended 60 minutes. So thank you very much all for joining to this presentation, to this very lively discussion today. Good questions. Sorry not being able to address all of those, but I'm sure we took some of the representative questions, and I look forward to you as the audience again. And thank you, Gerd. It was my pleasure to have you again here in our Vector Forum, but also being together with you. Good success to Healthineers, and thank you again.
Thanks a lot, Christof.